In this video, I'm going to go over the Let's Get Takeout project from the Learn Intermediate Java course on Codeacademy. I'm creating this video because I struggled with this project a couple of months ago, and I really wish there was a video like this one that was out there on the internet, but unfortunately there are no tutorials from Codeacademy or any other site that go over this project, and the forum posts on this project are very limited, like less than 10. So without further ado, let's get right into this project. But we first must acknowledge what this project entails. So this project is one that creates a takeout system. So like an online takeout system. We're going to use the collections framework, generics, and just our general knowledge of Java to do this. So it is going to require a lot of classes, 2 interfaces, and a couple of methods. Some will be generic and some won't. Okay. So the first step is to create a customer class. So let's go ahead and tab over to customer.java and read what the step 1 says. It says, create a class called customer with 2 private fields, string name and int money, include getters and setters, which are public for these 2 fields, and a constructor that initializes the name and money parameters to these 2 fields. So I'm going to go ahead and paste in the solution. The reason being is that this is fairly straightforward. The more complicated parts of this project lie in the last 5 sort of steps. Steps 15 through 19 in particular are the hardest because they require Lambda expressions and other things. So yeah. But basically, just going over it, we have a customer class, we have our fields, which are private, our constructor initializes those fields, we have our setters, these are our getters actually, and then we have our setters here. So there it is. Let's move on to step number 2. We're going to create an interface that will represent an item in our takeout system that has a numeric price. So in pricedItem.java, create a priced item interface with a t-type parameter that is upper bounded by number. It also wants us to define the abstract methods getPrice and setPrice. GetPrice has a t return type and no parameters, and setPrice has no return value and a t-type parameter called price. So here's the code. It is pretty straightforward. Here we define a public interface called pricedItem. And here we give it the t-type parameter, which is upper bounded by number. We use the extends keyword to upper bound. Here is our getPrice method, t return type. And here is our setPrice method. It doesn't return anything. So it's that simple, guys. Let's get on to step number 3. We're going to be creating another class. This class is going to be called food, and it will implement an integer type priced item. So essentially the way that's going to look is it's going to be like this priced item and then of type integer. And then we also want to have 3 private fields, string name, string description, and int price. We should create a constructor that initializes these fields. So pretty straightforward, similar to what we did in customer.java, except we don't have to do any of the getters and setters. So we're going to do step 3 and 4 together. So I'm just going to go over and look at step 4 as well. So in this food class, we're going to override a couple of methods as well. So we're going to override the setPrice and getPriced item of the priced item interface that we just defined. And then we're also going to override the toString method. And this is just so we can provide a description of the food object so that we can display it onto our menu. This is what an example description looks like below. We're not going to make it look like that because that doesn't look that good in my opinion. But let's go ahead and look at the code. So here's the code. Let's go back to step number 3. Here we define our food class. It implements the priced item interface of type integer. The reason why we have to specify the type is because our food class is non-generic. So when we're implementing a generic interface, we do have to specify the type. Okay, here we have our private fields and our constructor, easy as. Then let's go down here to step number 4. we override the get price and set price methods so that they in the get price method we return an integer, and for set price we take in an integer. Reason being, once again, priced item is of type integer. And then lastly, we override the toString method to just provide a description of the food object. So it will return the name plus the description, and then here I just created this little arrow thingy and the price. So that's step 3 and 4 done. Let's move on to step number 5. Shopping bag. Okay, so to take our takeout food home, we need a shopping bag. In shoppingbag.java, create a generic shopping bag class with a t-type parameter upper bounded by an integer type priced item. In shopping bag, create a private field called shopping bag, which is a map of t to an integer. Also create a no argument constructor that initializes shopping bag to an empty map. So let's look at the solution. So this is what the solution looks like. We create a class called shopping bag, which is upper bounded by an integer type priced item with the generic t type parameter. So same thing that we did in the food.java, but here we implement priced item. In this case, we are upper bounded by a priced item of type integer. And then it also asks us obviously to create a field, which is a map of a t to an integer. So we declare private map t to an integer shopping bag. Then we create a no argument constructor that initializes shopping bag to an empty map. Here is the line where we initialize shopping bag to an empty map. I was a bit confused on this initially because like when I first started working on this project months ago, because of the wording here, but essentially you're just declaring your map on one line as the field, and then you initialize it in the constructor. Let's move on to step number 6. Okay, so let's get started with step number 6. This one's a quick one, but it is pretty informative. So we're creating our own method here. It's called add item. It accepts a t-type parameter called item, and it doesn't have a return value. Inside add item, if item already exists in shopping bag, increment its value by 1. If item does not exist in shopping bag, map item to a value of 1. So to understand what this method exactly does, we need to understand what our shopping bag, which is a hash map, maps to and from. So it maps from a t to an integer. T is going to represent the food item in our shopping bag, and the integer is going to represent the number of that particular food item in our shopping bag, or the quantity. So if we have rice, for example, as the key, which is represented by t, it would map to the number of rice or rice packets or whatever in our shopping bag. So let's say 11, right? That's how it works. So that's why if the key or item is not present in shopping bag, we have to map its item to a value of 1, because that's the first of that particular food item in our shopping bag. So here's the implementation. It doesn't return anything. It takes in a parameter t item. We use the contains key method for this particular implementation. You can use shopping bag.get item is not equal to null as your condition. That works as well. But as you guys can see, it's relatively straightforward. It does exactly what we're asked of, and it doesn't require much other than 5 lines of code, right? So it's a pretty easy one. Let's move on to step number 7. Okay, so for step number 7, we're going to have to create a second method called getTotalPrice. Now, let me preface this by saying that this step is written really poorly, the description. It doesn't tell you that you should create a getTotalPrice method. It just says inside getTotalPrice, blah, 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 right? So as you guys can see here, all of the other steps will ask you to create a method called X, or do this, create a generic class. But for step number 7, it doesn't. It just says inside a method, which we haven't yet defined, right? So I was confused by this when I did this project a while ago, but yeah, you're just gonna have to sort of infer that this is a new method that you're going to create. So yeah, let's get right into this step. For this step, we're going to calculate the total price of each item and return the grand total. So that's pretty much what we're doing. We're going to iterate through each item in shopping bag and multiply the item's quantity by its price. We're going to sum up all of these prices and find the grand total of everything in the shopping bag. So here is the implementation of the get total price method. We create a variable called total price, which is set equal to 0 initially because, well, we don't have anything. Then we use the entry set method to iterate through shopping bag and have access to both the key and the value at the current item or entry. We use some variables to store quantity and item. We get the item total price by multiplying the item's price by the quantity, and then we increment total price by the item's total price. And at the end, we just return total price. So this method, once again, it's not super complicated, but it's not really worded well. But yeah, that is step number 7. We have designed a pretty solid shopping bag class so far, where we can add items and get the total price. Now, for this project, we're actually not going to create a remove items method, but it's definitely something to look for if you want to expand upon this project when you're done, because you genuinely can't remove items from your shopping bag once you add them. So yeah, but let's move on to step number 8. Step number 8 asks us to tab over to foodmenu.java to create a food menu class with a private field called menu. And menu is a list of food. We're also going to create a no argument constructor that initializes menu with some food objects. It says try creating 3, but for the purposes of this project, we want to have more than 3 items. So I've created 17 food objects. So we have a pretty diverse menu. But let's first understand, why were we creating foodmenu.java? Well, it's because we need to be able to display a menu first off, and be able to alter our menu whenever we want to, right? Let's say one day we want to add spaghetti to our menu. We can do that. So this is the code. Essentially, we define a public class called food menu, and it has a private field, which is a list of food called menu. Our constructor doesn't take in any arguments. It just initializes menu, which is our field, to a new array list. And then we use the add method of array list to add new food objects, right? We have to add food objects to our menu, right? So here's 17 food objects. Now if we go back to food.java, we'll see that each food has a name, description, and price, right? And these are initialized through the constructor. So in food menu, we have to pass those in. So for example, this food is called a grilled cheese sandwich. Its description is made with cheddar cheese on sourdough bread, and it costs $12. Don't know if that's cheap or expensive, but that is, in this day and age, I'd say that's probably pretty cheap. So yeah, let's go ahead and move on to step number 9. This is a pretty straightforward one. Okay, so for step number 9, we're going to create a method that allows us to display our menu to customers. So we're going to implement a custom toString method. So that's that. We're going to be overriding toString and returning a string that contains all food objects in menu, where each food object has an identifying integer index so customers can easily order food. So this is what an example toString method would return. Something like an ordered menu where we have 1, 2, and 3, and then just a description. So you'll notice that we created a toString method for our food class that will return this description. Here, it looks awfully like this description, right? And that's exactly what we're going to use in our toString method for food menu. This time, However, we're going to iterate through every food item. So let's look at the implementation. At override, public string to string, and let's just quickly jump to this for loop. So it's an enhanced for loop, and it says for each food item in the menu, and then we append, or we concatenate, actually would be the better term, a string to return string. And return string is just the variable here that I define that is going to be returned at the end of our toString method. I use a count variable, which is initialized to 1 to act as our identifying integer index, and it's simply incremented after every iteration of the for loop. So we just concatenate return string with count plus a period so that it looks like this, and then item, which is the current food item we're iterating over in the menu, dot toString. So this is where we're going to get the items format like this: tacos, yummy steak tacos, cost 15, in a new line. So this is just one of the ways we can do it. We can also use the string builder, which works just fine, and some people might say it's better and you should do that instead. But, to each their own. I feel like this is simple enough. It's like 6 lines of code, and it does the job. You could use a regular for loop, but to me, using an enhanced for loop and just creating your own count variable or counter variable is simpler, in my opinion. So I just do that, but the overall sort of approach is the same. You will iterate through the entire menu and concatenate that food item's representation, which consists of the name, description, and cost, to a string, which will be returned at the end of the method. So that's step number 9. Let's move on to step number 10. Step number 10 requires us to create a getFood method. And this method does exactly what you would think it does. It just returns the food item at a specified index. If we can't find that food item because the index is out of bounds, then we just return null. It's important to note that lists have zero-based indexing, but our menu item numbers will start from 1. So that's just something that is important to note to ensure that you don't have any sort of mistakes in your code because of that. So the reason we're creating this method is pretty self-explanatory. It's just so that when our customers use our menu, they'll be able to actually pick a food item by its item number. So here's the implementation. It returns a food item. It takes in an index. But you do have to remember that this index is not zero-based. It starts at 1. So the first check we do is if index is greater than menu.size. So if index is greater than menu.size, that means that the index would be out of bounds. We return null then. Same thing with index less than 1. And then we don't even need to include an else block, because if we don't return null, that means that the index is within bounds. So we can just return menu.get at index -1. -1 once again because lists are zero-based indexed. Pretty simple. Let's get on to step number 11. Step number 11. When using our menu, we'll often want to quickly know what the lowest cost food item is to get the best bang for our buck. Okay, so just note based off that, it looks like we're going to want to create a method that will get or return the lowest cost food. And that's exactly what we should do. This method doesn't take in any parameters because we don't need to, and it just returns the food object in menu with the lowest price. Here's my implementation. So let's take a look at this method. It returns a food object, doesn't take in any parameters. The basics of this method are pretty uniform across the varying implementations. You're going to use a for loop, or just a loop that goes through each item in the menu. Especially because the menu is of very little items, right? My menu has 17 items, but really you're not going to build a menu for a restaurant that's going to have more than 100 items. unless your restaurant is really big. So, okay, the way we approach this is we create a food variable that is called cheapest, and it's just going to be the first food item in the menu. So menu.get at index 0. Then we're going to iterate through the menu. So for each food item in the menu, if the current item we're iterating over's price is less than cheapest dot get price, so cheapest's price, which is initially set to be equal to our first item in the menu, then we set cheapest to be equal to that item. So now cheapest will store a different food item than the initial food item that it stored, which was the food item at index 0. This isn't guaranteed to happen because the food item at index 0 might be the cheapest one, but most of the time it won't be, so we will be updating the cheapest variable that way. But essentially we're just comparing the current item we're iterating over's price to whatever is set to be cheapest. So by the end of our for loop, we will have cheapest to be equal to the food item with the lowest price. So at the end of our method, we just return cheapest. That's how I implemented it. Let's move on to step number 12. Okay, so for step number 12, we're going to move on to a different part of the project. It's called simulation plumbing. So let's go ahead and read over what we have to do. We'll need to be able to take in user input in our takeout system for customers to order food. We'll be working with an int type user input to drive various prompts in our takeout system. Let's create a generic user input method to keep our code dry and reusable. In int user input retriever.java, which we're currently hovering over, create a generic interface called int user input retriever with a t-type parameter. Int user input retriever should define an abstract method produce output on int user input, which has a single int type parameter called selection, returns a t-type object, and may throw an illegal argument exception if selection is not valid. So here's the implementation. This is not necessary, this annotation here, which says functional interface, but this is an interface that is considered functional because it has one abstract method defined within the interface body. So once again, public interface, int user input retriever, t-type parameter, straightforward. Our method returns a t-type. It's called produce output on int user input, and it takes in one parameter, int selection, and it also throws a legal argument exception if selection is not a valid selection. So the definition of the interfaces, this is the second one we're going to do for the project, and the last, they're straightforward. What's more difficult is actually implementing these interfaces, which we will do in Takeout Simulator class here. So let's move on to step number 13. Step 13 requires us to move over to takeoutsimulator.java to create a Takeout Simulator class with 3 private fields: customer type called customer, food menu type called menu, and scanner type called input. We also have to create a constructor that initializes customer, menu, and input. So this is essentially the class where we create a takeout system. We're going to be able to get user input, allow customers to add food to their bags, and check out. Here's the implementation. Public class takeout simulator. Here are our private fields: customer, food menu, and scanner input. Let's look at our constructor in more detail. So our customer only takes in 2 parameters: a customer type customer and input type scanner. So as you guys can see, we're not taking in a food menu object as a parameter. Reason being, inside of our constructor, we're just going to be initializing our menu to be equal to a new food menu. Again, the reason we're doing this is because our menu is going to stay the same. We're not having someone pass in a menu as argument when we create a takeout simulator object, because that doesn't make any sense. Our menu is going to stay the same, but our customer will change, and we're passing in our input, which is a scanner, because we're going to be using that scanner in our main method before we actually create any takeout simulator objects or anything of that nature. So that's the sort of explanation behind this constructor. I personally, when I first started doing this project, I did not understand what I had to do here. So I just kind of said this dot menu equals to menu. But if you just think about it from a design perspective, you understand why I'm not taking in menu as food menu as a parameter. It doesn't make sense. So that's step number 13. Let's move on to step number 14. Step number 14. Okay, so for this step, we're creating a get output on int input method. And let's look at the reasoning behind it. So we'll need to be able to prompt users for their input in various places to use the takeout system. Let's create a generic method that will prompt users for an int input and perform some operation on it. So first, let's think of places in which we're going to use the takeout system, and particularly where we're going to have to prompt users for, a particular input. Well, one of those sort of cases would be to see if our user or customer, would like to continue shopping, right? Maybe they are done. They got all the items they wanted. They want to check out. Well, it would be useful to have a method, and we're going to design one later on in this project that checks on that Boolean expression, and it requires us to grab some user input. So we're going to create a generic method that we can reuse in various different parts of our code, keeping your code dry and reusable. So in Takeout Simulator, create a generic private method called getOutput on int input that has a string parameter called user input prompt, an int user input retriever parameter called int user input retriever, and returns a t-type reference. In getOutput on int input, create an infinite loop that performs the following tasks. Display user input prompt, which is a string that's passed in as an argument. Get the user input. If an int was provided, retrieve it and attempt to call produce output on int user input of int user input retriever. So this is the method within the int user input retriever interface with the retrieved int user input as argument and return the result. If an illegal argument exception was caught, calling produce output on int user input, we will display a message telling the user their input was not valid. Finally, if the user did not provide an int type, we will also display a message telling the user that it needs to be an int, and we'll try to obtain the next integer. So these are some example prompts. 5 is not a valid input, try again, or input needs to be an int type. So this is, once again, very much more complex than the previous methods that we wrote. Let's take a look step by step at the implementation. So this is a private method, and it returns a t-type, and its type parameter is also of type t. It takes in string user input prompt and int user input retriever, matching type, int user input retriever. We can call this whatever we want. Once again, this is just a reference to the int user input retriever interface, but we're just going to call it the same thing for the purposes of this method. Then we create a while true loop. When it says create an infinite loop, that's pretty much what it's asking you to do, create a while true loop. System.out.print user input prompt. Well, we're just printing out the user prompt. Then get the user input. Okay? Well, before we get the user input, we need to check if there is something that we want to get. So we use the hasNextInt method to make sure that there is a next int to grab. And if that is the case, then we can store input.nextInt in a variable, and then we can use input.nextLine to clear the scanner. Then we will use our try-catch block, because so far there's no exception, no error that's going to be thrown. We're going to try to return int user input retriever dot produced output on int user input, passing in user input. Now let's break this down. User input is, simply put, the input that we just captured here. Produce output on int user input, that is the method that is located within the int user input retriever interface. Produce output on int user input. Then let's go back. Int user input retriever. This is a reference to the interface. what we're going to be passing in as this int user input retriever reference is actually a Lambda expression. So what happens is when we call produce output on int user input, the selection is going to be user input, but the implementation of the method is defined by the Lambda expression that was passed in as an argument. This is pretty hard to grasp if you're just starting to learn about Lambda expressions in Java. So I ask that you bear with me and wait until we actually implement some of these Lambda expressions, because that will make it a lot easier to understand. So right now it's perfectly fine if you don't understand what this means, but I will promise I'll go back to this code after I go over the Lambda expressions in the methods we will define shortly, and it will make a lot more sense. So let's proceed. We will catch an illegal argument exception and print out the user input, quote, is not a valid input, try again. Else, that means that the user didn't provide an int type. So we have to prompt the user to, or at least let them know that the input needs to be an int type, and then once again try to obtain the integer from the input using input dot next. So that is the method, and it's pretty complex. There are people that try to do something like this, well, where they'll remove that and they'll use a wildcard here. But if you do that, you have to return this function call and cast it as a T object, and you'll still get some like type safety issues, or sorry, T type. But yeah, you don't want to do that. Instead, just use this syntax and it'll work just fine. So yeah, let's move on to step number 15. Okay, so in step 15, we're going to actually call the method that we just defined, get output on int input. And yeah, it's gonna be fun. So let's get right into it. So in Takeout Simulator, create a method called shouldSimulate that accepts no parameters and returns a Boolean value. So this method essentially creates a way for users to exit the Takeout system gracefully. Now, granted, after completing this project, I realized that this method is pretty much useless. Reason being, we're going to create a method called, let's go ahead and take a look, checkout customer, that basically just should end the program, right? Like, it doesn't make sense that we create this method. But anyways, we're going to do it because it's part of the project. So this method accepts no parameters and just returns a Boolean value. Makes sense. Create a string called userPrompt that contains a message to prompt users with an input of 1 or 0. This is where the Lambda expression comes into play. So remember, when we have a functional interface, meaning an interface that contains one abstract method, we can create an implementation of that method using a Lambda expression. This is taught in the Learn Intermediate Java course earlier on. So whenever you see this kind of keyword, create an implementation of int user input retriever, well, we know that that points to our functional interface. We're going to be creating a Lambda expression. Okay, and then let's just quickly look at this. We're going to be calling get output on int user input, pass in user prompt, and the created implementation of int user input retriever. So hopefully that makes more sense. We're going to be passing in our own implementation of int user input retriever. So that's what this stands for, that implementation. That's what defines the behavior of this method. So let's look at the implementation. So we create our user prompt, which is just, you can do whatever you want, but this is how I did it. Then we create our Lambda expression, which is an implementation of int user input retriever. So note that our Lambda expression is of type Boolean, right? Because we were returning Booleans. We can then call our Lambda expression whatever we want. In this case, I just call it int user input retriever. S in this case stands for our parameter. If we go back Here it's called selection, but we can call it whatever we want. It's inferred, or Java infers, that we mean that parameter. Then we use the syntax arrow and then the curly braces to start our Lambda expression. So if s equals 1 and our customer's total money, which is the way we can access that is using the get money, is greater than or equal to menu.getLowestCostFood.getPrice, will return true. What that means is that the user wants to continue to shop. They want to continue shopping or like navigating the takeout system, and they have enough money to actually purchase the lowest cost item. Because if they don't have enough money to purchase the lowest cost item, it doesn't really make sense for them to be navigating the takeout system, right? So we're not going to allow them to do so. So else if s is equal to 0, then that means that our user wants to exit the program. So we will thank them for eating with us and return false, meaning we should not simulate. Else we will throw a new illegal argument exception as specified. Here it says this method should throw an illegal argument exception if selection is not 0 or 1. Finally, we call getOutput on int user input. Now, keep in mind, this is a typo that Codeacademy wrote. The method's not called getOutput on int user input. It's called getOutput on int input. So you should actually call getOutput on int input. So this is the second mistake Codeacademy makes. This tripped me up completely when I was working on this project. So, yeah, this project, to be completely honest, was not, designed great in a great way. I mean, two directions that really throw people off. No tutorial online that is provided by Codeacademy. I mean, a lot of things wrong with this. So I hope that this helps you out. But yeah, you're really going to be calling getOutput on int input here. And you pass in the user prompt and your created implementation of int user input retriever, which is a Lambda expression once again. So that is our step number 15. Let's move on to step number 16. And just to note, step number 16 is very similar. We're going to create an implementation of int user input retriever. Same thing with step number 17. So 16 and 17 are going to be relatively similar. So if you're able to grasp step number 15, then the steps number 16 and 17 will come naturally to you. So yeah, let's move on. Step number 16 is going to look an awful lot like step number 15. Let's get right into it. So this step is going to ask us to create a method called getMenuSelection. Basically, we're going to display the menu to the user, ask the user to pick one of the menu items, and yeah, that's what that method does. So it will return a food object, which is the food object that the user wants to consume. So yeah, this method can be broken down into 3 parts. Similarly, our previous method could as well. We are going to create a string called user prompt and an implementation of the int user input retriever using Lambda expression and call getOutput on int input. Remember, this is a typo. Int user input, it's just int input. Same exact thing we did here. String, Lambda expression, call the function getOutput on int input. That's why what I was saying previously is makes sense. So let's look at the implementation here. Essentially, we print out our menu options in the menu. Remember, we defined overrid a toString method in our food menu class. Here's where it actually comes into play. Create a user prompt, which is string here, choose a menu item, prompts the user to choose a menu item. Here's our Lambda expression, which is our own implementation of the functional interface. We have a type parameter of food in this case instead of Boolean. And then we use this sort of syntax here to create the Lambda. And now let's look at what's actually inside it. So if menu.getFood, passing in the selection, is not equal to null. So this is a logic that I could have implemented in one of the earlier methods where I pointed that out. Here I implement it. Well, that means that we can return the menu item because it exists in the menu. Else we throw an illegal argument exception. It's that simple. let's just look over the directions to see if this makes sense. Create an implementation of int user input retriever that gets the food item using selection from menu and returns it if it's not null. There it is. Else throw an illegal argument exception. Okay, finally, we're going to call get output on int user input and pass in user prompt in our created implementation of int user input retriever. So here this line of code does that, and note that it's the exact same thing that we did for our previous method. So here's an example prompt. It's going to print out today's menu options and then the menu. It's going to ask you to choose a menu item. So yeah, that's step number 16. Let's go on to step number 17. Okay, so for step number 17, we're going to be creating a method called isStillOrderingFood. It will accept no parameters and returns a Boolean value. So similarly, the method should_simulate does the same thing, right? It doesn't take in any parameters, it just returns a Boolean. Should_simulate, is it yes or is it no? True or false? Same thing with it excuse me, isStillOrderingFood. It will return true or false, right? So let's go ahead and take a look at what we're gonna do. Same thing, once again, create a string called userPrompt. In this case, it will contain a message to prompt users for an input of 1 to continue shopping or 0 to check out. Create an implementation of int user input retriever, returns true, selections 1 and false, selection 0, and then it will throw an illegal argument exception if not for those two cases. And lastly, we just call get output on int input, passing in user prompt and this implementation. So I'm not even really going to go over this. It's basically the same logic as the previous two methods. The lambda expression has a different implementation. If s equals 1, return true, else if s equals 0, return false, else we throw the illegal argument exception. Makes sense. Let's move on to step number 18. Okay, so step number 18, and we're moving on to a different part of the project. Final part, ordering food. So once the customer is finished ordering, we'll need a way to process their payment. In Takeout Simulator, create a method called checkoutCustomer with a single food type shopping bag parameter called shopping bag that returns no value. This method should, let's read this, inform the customer that the payment is processing, calculate the customer's remaining money after paying for the total cost of food and shopping bag, update customer's money with the remaining money, inform the customer of the updated money they have left, and display a friendly message telling your customer to enjoy their meal. This is an example message. So for this method, we will be utilizing some of our other methods that we created, particularly set money from customer and get total price from shopping bag. So let's go ahead and take a look at the implementation. It doesn't return anything. Checkout customer, and once again, it takes in a food type shopping bag parameter called shopping bag. Processing payment, print that out, and then we create this variable called remaining money, which is simply equal to the customer's money minus the total price of all the items in the shopping bag. So that's where our get total price money and get total price method and get money methods come into play. So yeah, then we just update customer's money with the remaining money by using customer.setMoney, passing in remaining money, and then we just print out what the remaining money is and thank them for eating our food. Simple. Let's move on to step number 19. Step number 19 is going to be one of the most difficult in this project for sure. We're going to have to create an entry point for the takeout system. So we're going to create a method called takeout prompt with no parameters and no return value. This method is going to create an instance of shopping bag type food and a variable to keep track of the customer's money called customer money left. After that, we're going to create a loop that performs the following tasks and stops upon user checkout. So once you read something that says like create a loop that does something until a certain condition, we can use a while true loop. But in this case, I went for a slightly different approach, although while true loop works as well. But we're going to display a message telling the user how much money they have left, prompt the user for a menu selection, and store the selected food object. check if the user has enough money left to purchase the selected food object. If they do, subtract its value from customer money left and add it to shopping bag. If the user doesn't have enough money, display a message telling the user they don't have enough money, and tell them either to pick another item or check out. And then finally, ask the user if they're still ordering food. So we're only breaking out of this loop if the user says they're not ordering food, because then we'll prompt them to check out. So once the customer is done ordering food, we will check out the customer. So an example prompt will look like this. So let's look at the implementation here. Public void takeout prompt. So we create an instance of shopping bag called shopping bag. We create a variable called customer money left, which is initially set to customer's money. And here's where I differ from the while true loop that I used earlier. Instead, I create a Boolean variable called still ordering, and I set it equal to true initially, and I'll update the value of still ordering to be equal to false later on in the loop. Not necessary, but I feel like it makes the code a little bit more readable, so that's why I did this. So while the condition still ordering is true, we will print out the customer's money left to spend. Then this is where we're going to call a previously defined method, which is called getMenuSelection. We're going to store the result of getMenuSelection into a food item. So remember, getMenuSelection returns the food item that the customer wants to acquire. So we're going to store that in a variable called item. Then we'll check if customer's money left is greater than or equal to the item's price, then that means that the customer can pay for it, right? So customer money left is going to be updated to reflect this payment. So we will be decrementing or just reducing customer money left by the price of the item. And then we'll add that item to the shopping bag. We call the add item method here. Remember, this method was defined in our shopping bag class a while ago, and here's where it comes to fruition. None of these methods that we defined earlier are useless, right? They all serve a purpose. They're usually like helper methods. They're being called inside of larger methods. And even getMenuSelection is being called inside of takeout prompt, which is interesting. And then else, we will just print out, oops, looks like you don't have enough for that. Choose another item or check out, because they don't have enough money for that. Right? Maybe they can afford another item that's cheaper, but we don't know for sure. So they have to choose if they want to continue or check out. Then we call the method called isStillOrderingFood, and we update our initial variable still ordering to be equal to the result or the return value. So isStillOrderingFood returns a Boolean expression, right? So if they're still ordering food, they still want to order food, it will return true, and takeout prompt, or at least the while loop inside of the takeout prompt, will iterate again. But if that's not the case, if the customer does not want to order anymore, then we will check the customer out and pass in shopping bag. So remember, for checkout customer takes in shopping bag as an argument, well, that's where we pass in shopping bag. And that will check the customer out. It will, at the end, say thank you and enjoy your food, and that's how we check the customer out. So this is how our takeout prompt method works. At the very end, it asks the user if they're still ordering food. So what that means exactly is you should call the isStillOrderingFood method that you created. So yeah, like if we were using a while true loop, essentially what we would do is if this returns false, we would break out of the while true loop. So yeah, that is the method. Let's move on to step number 20. This is the second to last step in our project, and it is a step that requires us to create our method that's actually going to be called inside of our main method called start takeout simulator. So let's get right into it. Step number 20, let's create a way for the takeout system to start its dialog so customers can order food. Let's create a public method called start takeout simulator. This method's actually going to use our previous method takeout prompt. We're going to call it. So it takes no parameters, returns no value. The method's just going to display a fun intro to the customer and loop until the customer wants to exit the simulation. So once you read this, you should probably think, oh, we're going to use the should simulate method as well that we created earlier. And yes, you're correct. But yeah, I do think that the should simulate method's kind of stupid. Doesn't make sense. The checkout customer method, I feel like, does the same thing. So yeah, I don't know why we have to do this whole thing with the simulation, but okay. But yeah, it is what it is. But then let's look here. It says in each iteration, display the customer greeting and start the takeout prompt. So the start takeout prompt, that's the keyword for call the takeout prompt method, right? So let's look at the implementation here. Public void start takeout simulator. We go along with the same logic we use here. We create a Boolean variable and then we use it as our loop expression or condition. My apologies. Do the same thing here. Boolean continue simulating equals true. While continue simulating, we print out a intro and greeting message. Here, welcome, customer.getName. Then let's move on to the part where we actually start the takeout prompt. Well, we call takeout prompt on the takeout simulator object. That's how we do it. Then we set continue simulating to be equal to the result of the function call or the method call should simulate. So if they want to still simulate, then we will do the same thing. We will continue simulating. We will go through another iteration. If they don't, we'll break out of the loop. Or, I mean, technically not a break, but the loop will stop. So yeah, that's how we do step number 20. One more step, and this is where we will actually create our main method implementation. So let's move on to the final step. Congrats if you got this far. Okay guys, so let's get into the final part of our project. Last step, we're going to be starting up the simulator to get some food. So I'm actually going to just provide the implementation right away and just go through it step by step. So here's the implementation. So in main.java, create an instance of scanner called input. Scanner input equals new scanner system.in. Reads from standard input. Prompt the user for a string. System.out.print, what is your name? Store it in a string called customer name. Then try to get an integer amount of starting money. Int money equals 0. Try money equals input.next int. Catch input mismatch exception. Invalid input. Please enter a positive integer. And we clear the scanner. The while loop is not necessary, nor is this Boolean, but I tried to make the program a little bit more rigid, so I included this extra functionality. Then we instantiate a customer with customer name and money as arguments. So here we instantiate our customer with customer name and money as arguments. These are the two variables that store the name and starting money that the customer has. Then we can create a takeout simulator object called takeout simulator, and it will take in customer and input as arguments. Customer, for this customer object we just created, and input, which is right here, scanner object. So this should clarify any questions you had about the customer in takeout simulator, the constructor in takeout simulator, only taking in customer and scanner objects as parameters. That should make more sense. And then finally, we can start our simulation by calling takeout simulator, the object we just created, dot start takeout simulator, which is our final method that we defined in our takeout simulator class. It's essentially what gets called to start our takeout simulator, and then there's just a sort of chain reaction of methods getting called. So we'll call the takeout prompt method inside of start takeout simulator. Inside of takeout prompt, we'll call checkout customer. We'll call is still ordering food, etc., etc. So essentially, our starting point for the takeout system is this method called start takeout simulator, And this does a really good job of encapsulating our data, right? I mean, there's not much to see here. So yeah, that's the project. Let's go ahead and see how it does performs. Let's go ahead and extend here. Okay, so it asks us for our name. Let's just say my name is Bob. And what is your starting money? Let's say I have 50 bucks. I'm feeling pretty solid. Okay. Names, table, and grill. This is the way I formatted it. You can do whatever you'd like, but insert name. Welcome, Bob. You have $50 left to spend. Our menu options. Okay, here are our menu options. Choose a menu item. So let's enter the corresponding number associated with the menu item. I'm feeling like, I want some chicken quesadillas today. Let's get some chicken quesadillas. 17. Okay. Would I like to continue shopping or check out? I'd like to continue shopping. Let's get something else. Okay. You have $36 left to spend. Our menu options. Let's get a grilled cheese. Grilled cheese, solid. And let's check out. Okay, processing payment. Your remaining money is $24. So since I had $50 to start with and my remaining money is $24, that means I spent $26. Not bad. Thank you and enjoy your food. Now this is the simulation part where it doesn't make sense to me. The Takeout project should just sort of end here, but it says enter 1 to continue simulation or 0 to exit program. If you click 0, it'll just stop, but let's just click 1 to see what happens. Essentially, it will start up a new prompt, basically. Like it'll tell you the name of the restaurant again, and it will welcome you back to the restaurant, and it'll tell you the same thing. So let's just choose like some easy option and just check out. And now finally, let's exit the program. Thank you for eating with us. Hope to see you soon. Nice. So yeah, that's our Takeout Simulator project. There's a lot more you can do with it. You can try putting in some inputs that don't work, like ABC for what is your starting money, or -5, and then you can mess around with it basically. But that is the Let's Get Takeout project. I hope that my video has helped you solve or understand different tasks or sort of steps for this project. It was a lot, and this video is going to be definitely pretty long. But yeah, I definitely enjoyed making this video. More to come in the future as I look back at some Codeacademy projects that I worked on that are not adequately explained online. So yeah, subscribe if you'd like to tune in to any further sort of walkthroughs on any Codeacademy projects. Thank you for watching. See you next time. Peace out.